Again, real quick overview of who I am. I'm a CCA in the state of Wisconsin. The green arrow in the top right points to where my location is. We're right on the 45th parallel, just outside of Minneapolis. I've got a background in biotech and nutrition. And as I mentioned, we also do a regenerative sweet corn and pumpkins operation here on our family's 3 acres. Those are 2 of my 4 boys on the left-hand side, and that is a 160-pound jack-o'-lantern. We absolutely love growing the biggest pumpkins here. I'll touch on that a little bit later in the presentation. Growing large pumpkins regeneratively is perhaps the pinnacle of my own passions, and I'll share a little bit about how we get to that using various types of regenerative practices. So there's a quick look at the pumpkin patch. I use a cover crop rye system where we're planting pumpkins directly into the rye. And as part of my efforts to be as regenerative as possible, this system requires no additional water except for what Mother Nature provides and no chemical herbicides in order to grow these pumpkin plants, because the rye does all the heavy lifting there. I absolutely love cereal rye as a cover crop. It is such an incredible, useful tool. And as a result of that, we've got an incredibly productive pumpkin patch, as well as really good soil to help us produce these pumpkins as cleanly as possible. But let's dive into this concept called the Haney soil test. I guess that's why I was asked to present here today. I've run about 120 of these things over the last couple years, and it's been an incredible learning experience. I promise I won't quiz you on the end of what you all see in the screen here. It's a pretty complicated set of data, and ask you not to be overwhelmed, because I'm going to do the best to break down what is the most valuable aspects of what we're looking at here. So when it comes to this Haney soil health test, you've probably heard a lot about it, and you may have some questions like, what does this thing do for us, and what can we actually get out of it? And before we dive into any particular parameter on this lab analysis, the first thing I want to mention is to know why we're going to run one of these tests in the first place. And to help you out with that decision process, I've kind of bucketed the Haney test into two different camps of what I think I've found its utility to be. So the first camp of why you'd want to run one of these tests is to set a benchmark for future comparison. If your operation is in the process of transitioning either practices or fundamentally from one category to another, it's useful to run one of these before you make a big change on your operation, especially if you're hoping that you're going to be able to measure beneficial change down the road. And so that's, I guess, in that particular context, if we were to just go out and grab a random Haney test on your acres today and come back and try to pull some meaning out of that, it might be really difficult to do. Sure, we'll see some numbers that'll get us into the ballpark on some measures of soil health, but really the most value out of this test comes when you compare one sample today and another sample down the road after you've made some sort of change. It's really good at being able to detect whether or not whatever changes you're making are having a positive impact on your soil health. So that's the first camp I wanted to mention about this change tracking over time, and that a single point measurement really isn't going to get you a whole lot unless you've got the ability to make a change and then measure something down the road. And then the second bucket is using various measures on this test for helping shape in-season decisions. And that's where I have the most experience using this test. Obviously, as I mentioned, working with row croppers up in this part of the world, and the importance of nitrogen management on corn, I am using this test prior to side dress nitrogen application to help me dial in how much nitrogen the soil has, and therefore how much we think the crop needs in order to maximize its yield potential. And so I could see a similar usefulness in your own operations as well, especially for crops that are requiring various amounts of nitrogen, whereas you can take one of these tests prior to the application of whatever amendment or fertilizer you're using, and then use that information to help you determine what is going to be the least amount necessary to produce the most amount of crop. That would be the second way in which I have found usefulness in this particular test. So with those things in mind, what I would like to do is just give you a little bit more zoomed in, closer look at how I'm using that in regards to managing the nitrogen aspect up to it. And we can certainly touch on a few of the other aspects of this as it relates to benchmarking future practice change, but I did want to zoom in briefly on the nitrogen piece because it'll give you a sense for exactly how I'm using it and whether or not you could see some utility for yourself there. So what makes the Haney test unique in its ability to measure nitrogen? I guess that's probably a really important question to touch on quickly. And the major difference is that the Haney soil test is going to measure a portion of nitrogen that you cannot find on any other type of soil lab test. If you were to go to the lab and say, hey, can you measure me some nitrogen in my soil? They're going to tell you, yeah, we can get you a nitrate and we can get you an ammonium. And that's about where that ends. What Haney brings to the table, and this is really the most interesting part that I feel, is that it measures a component called water extractable organic nitrogen. And I'm sorry, I'm going to back up the slide here and see if I can hopefully you can see my cursor. The water extractable organic nitrogen is this part right here. You don't find that on other lab tests. They're just simply not measuring for it. Now, what this measurement represents are things like amino acids and other soil microbial parts that have nitrogen in them that just wouldn't be picked up in traditional soil testing. So it's nitrogen that's in what we call the organic form. And by organic here, we mean it's attached to a carbon molecule. So that's a really unique and interesting way to measure nitrogen. We know there's a lot of that in the soil because there's lots of microbes doing lots of things that create a lot of this organic nitrogen, but this is the only soil test that actually picks that up. So when we take all the various different ways that the Haney test measures nitrogen, it allows us to have a more complete picture of what the soil is capable of providing to a crop. And so I'm going to call your attention here to this nitrogen comparison part that's on the screen. You can see in a traditional test, in this particular example, it told us there was 33.8 pounds per acre of nitrogen in the soil. And when we factor in that part that Haney offers that you can't get on another test, you see that number goes up to 57.3 pounds, making a difference of 23.5 pounds. Now, to put that into context, in the corn growing world, 23.5 pounds of nitrogen per acre is kind of a big deal, especially when margins are really thin. And for any garden operation or farm operation that is looking to save as much cost as possible and not put excess fertilizer out there, we know the environmental consequences of doing that as well. This is where this test really can offer some advantage. As an agronomist building a nitrogen program, if you don't have the Haney test, you're building it based on this number here, the 33.8. You're missing out on 23 pounds that's there that you wouldn't have otherwise taken credit for. I now have the ability with this Haney measurement to do a much more accurate prediction of crop need for nitrogen. That's a pretty neat tool to have. I've done a lot with that. In fact, Wisconsin even provided a grant program to help study the usefulness of this test to help make those predictions. And pretty excited to say we've made a lot of leaps forward by using this particular test in that capacity. So before I transition away from this part of the Haney test, I also want to bring to your attention a few of the other numbers that you might find interesting. And these would be really interesting in the context of measuring practice change over time, to know, are the things that you are doing, whether it's cover cropping or reducing tillage or adding some biological amendments, are they having a positive impact on your soil health? So to call your attention to the bottom, or where my cursor here is in the soil health area, you're going to see that there's 1, 2, 3, 4, 5 different ways that they provide a number that is relevant to soil health. Now, the first one of these, I find this particularly interesting, is called soil respiration. So they're measuring the breathing rate of microbes. And that's a pretty neat way to get some sort of number behind how microbially active is your soil. So as we know, microbes, they breathe oxygen and they release carbon dioxide just like humans do. And so they'll take a sample of the soil and they'll put it into a jar and they will measure how much CO2 is produced. And that CO2 production then is essentially a proxy for how much microbial life is in your soil. So over time, as you do things that are beneficial to your soil, you would expect to see that your soil respiration value will go up. And that's exactly what happens. In really rich compost, you'll find respiration values that'll be up in the 300 or 400s. And so this is a very easy way to see a beneficial difference on the impact of soil microbes by making the soil respiration number. The next one here, organic carbon, and I apologize, we're not going to dive too deep into the weeds. This is going to be a really boring presentation. I just want to quickly run you through some of these soil health measures so that you understand the relevance of them. Number 2 here is called organic carbon. So organic carbon is the food that the microbes eat. And obviously, if you want more microbes in your system doing more good things for your soil and your plants, they need to be fed. And organic carbon is the food they eat, and we can measure that. And so you can see here this particular value of 96, that number probably doesn't mean much to you, doesn't mean much to me either, because again, this is all a relative comparison. Over time, as you do things that are beneficial to your soil, cover cropping, minimizing tillage, biologicals, what have you, you would expect that the total food level that the microbes can eat will go up. And this is exactly what we tend to see. If you're doing heavy cover crops, things like grasses, cereal, rye, oats, barley, sorghum, sudan, what have you, those grasses tend to pump more carbon into the system, which then becomes food for microbes, and the system becomes happier because of that. So that's a really neat measurement as well that can reflect practice change over time. The MAC percent number, this one really gets deep into the weeds. That is a measurement that gives us an indication of how much of the carbon is being consumed by these microbes is in the organic fraction. Essentially what we're looking for here is a number that's less than 100. If it's less than 100, it means that your microbes are eating your organic carbon and they're not chewing away at your organic matter. Ideally, we don't want microbes chewing away at precious organic matter because that would serve to bring it down over time. So the way in which we prevent that from happening is feeding them more organic carbon, which is different from organic matter. And that organic carbon, again, coming from things like cover crops, keeps the microbes well fed so they don't have to chip into your organic matter pool. And then the next one, there's carbon to nitrogen ratio. It's important that we always seek to have balance in carbon to nitrogen ratios. This keeps microbes happy and chugging along. If either of the carbon gets too high or too low, or nitrogen gets too high or too low and throws that balance out of whack, then the system starts to slow down, and as a result, plants can start to suffer. And so as we continue to look for ways to balance our inputs into the soil, that being carbon, the microbe food, as well as nitrogen, another type of microbe food, we're looking at that number and trying to keeping that within a pretty tight range. And that range, somewhere between 12 and 15 is a pretty sweet spot for carbon and nitrogen. The last number on here that I'm going to poke on a little bit before we transition away from this is called the soil health score. And so the folks here at this particular lab take all these numbers on the soil health measurement, they lump them into a proprietary algorithm, and they spit out an overarching number that represents a little bit of everything. And again, this number doesn't have any meaning as a single digit on a piece of paper. It is meant to be a relative comparison for something that you do in the future that can be looked back upon and say, yeah, I increased my soil health score by a full point. And so that's where the value in these types of numbers come from, is being able to compare them to something down the road. And so I'll probably beat that horse plenty good to death. I guess if that's one takeaway I had for you today, is that if you're interested in running this Haney test, make sure that you're budgeting and planning to run another one down the road after you've made some sort of practice change on your operation. Now, I'm not going to tell you to don't go do one. Certainly, if you're interested in doing one, go ahead and do one just to get familiar with it. But if you really want to extract some value out of this test and be able to use it as a way to benchmark what is happening on your operation, plan to do one here, maybe next spring when the system wakes back up. Make your changes, do your thing, and then come back the following spring and do the same thing roughly the same time and see how things have changed over time. That's really where I think the power of this test can start to manifest. So I'm gonna pause there just for a minute, because when I'm in the full screen presentation mode, I can't see if any questions pop up. I'm gonna check the chat log here before we dive back in. And again, if you've got any questions on that Haney test, feel free to throw them in the chat. I don't see anything that's come in here quite yet. So if you do, put them in. Super. Then I'll just keep chugging along, and feel free to put your questions in there if you got them, and we'll carry on here with a few more slides. Okay, so we talked about the soil health testing there with the Haney test. I want to talk a bit about mycorrhizal fungi. And mycorrhizal fungi are kind of a big deal to me, and I want to explain why they probably should be a big deal to you as well. In fact, I go as far as to say that they might just be the most important species on the planet, and that may even supersede us humans. And I think I'll do my best I can to try to explain to you why I feel that way. So if you're not familiar with mycorrhizal fungi, these are microscopic microbe that create beneficial relationships with plant roots. And the way that I kind of visualize mycorrhizal fungi, they're like the Charlotte's Web of the underground. And so they create these giant networks like spider webs that essentially go out into the soil profile. They grab nutrients and they grab water and they grab other things, and they bring them back into the plant system in exchange for carbon. So the plant feeds sugars to these mycorrhiza, and the mycorrhiza in return go out and grab nutrients that the plant roots can't otherwise reach. Some experts say that mycorrhiza expand the root system of a plant by over 100x. So this is a guy I want on my team at all times, because if there's any way for us to significantly expand the root system of a plant, I'm very interested in that. I mean, that directly translates the plant productivity for all species. And so that's why I place such an emphasis on these mycorrhiza. Now, there's more reason why I think these are even more important, especially in organic systems. And the reason why I feel that's the case in organic systems is because we know that tillage is a primary tool for weed control in organic systems. And tillage, unfortunately, is the worst enemy of mycorrhiza. If you remember, I said they create these spider webs underground. These are slow growing spider webs. They establish themselves in terms of years. And so if there's disruption to the soil profile via tillage, unfortunately, these spider webs get broken up as frequently as the ground is tilled, and therefore we lose the effectiveness of these networks. And so there's ways that we can overcome this hurdle. I recognize we just simply can't abandon tillage for the sake of mycorrhiza, because then the weeds take over and we're back at square one. So is there a way for us to have our cake and eat it too? I'm always trying to think down these paths. Is there a way for us to have our cake and eat it too? And my answer is, well, I think so, somewhat kind of. And so that's why I think I wanted to put this in here today, especially for those of you who are growing organically, to recognize the importance of mycorrhiza and how you might be able to put these to work in your crops for some benefit. So what I want to do is show you some data that I have on using mycorrhiza. Now, granted, this isn't a corn system, but mycorrhiza benefit nearly every single species on the planet except for the brassicas. So apologies for those of you and the brassica species. They just don't play nice with brassicas, but every other type of crop you're growing, they do play nice with. And so it's worthwhile to consider that, because I'm guessing there's a lot of operations growing more than just brassicas out there. Anyways, just to get straight to the punchline, they produce mycorrhiza in a biological product that works as a seed treatment. So this comes as a powdery dust. You coat your seeds with this powdery dust. You plant them in the ground. The mycorrhiza start to grow with the plant root. They set up their spider webs underground, and over the course of the growing season, you can reap the rewards of a robust mycorrhizal network within the confines of a growing season time frame. And so when we do this in production corn, we are finding that this is offering a 5.1 bushel advantage in field corn, 62% win rate, and that's a statistically significant number. And so to give you some perspective at what 5.1 bushel is in the row crop corn world, it's a really big deal. It's a pretty significant advantage. And what gets me excited about this is that, we live in a world now where every company out there has a biological product that they're trying to sell farmers. And very few of these products have ever come back and shown that they can consistently produce positive ROI year over year. And I'm here to share with you that I personally believe that this mycorrhizal fungi is one of the very few biologicals that I feel has a place on just about every farm, regardless of what they grow. Obviously, as I mentioned to you, work for this horseradish. Horseradish is a brassica. We can't use mycorrhiza on horseradish. Likewise, these other brassicas, again, we just are not going to be able to make this system work. But for any other type of crop that you're growing, there is a place for mycorrhiza, I believe, to help you increase productivity. It's better for drought tolerance as well, because they bring water in from the soil profile that the roots can't get to, as well as other micronutrients and such. And again, emphasizing that I especially think this is an advantage for organic growers who unfortunately have to use tillage as a way to control weeds by virtue of disrupting the soil network. So the other chunk of data I want to show here, this is in soybeans. We see 4.2 bushel advantage in soybeans, 75% win rate. Just another set of evidence here that even in a completely different crop and legume, we also see a significant response at the field level in that particular crop as well. Pretty darn exciting. And so that kind of then serves as a transition to what I wanted to talk about in the soil health testing arena. Not only can we do things like the Haney Test to test for soil health, but there's also tests out there where we can measure the types of soil microbes that are in your soil. And so here again, similar to the Haney Test, we have the ability to measure something, make a practice change, and then determine whether or not that practice change has had a positive beneficial impact. And here, this is called the PLFA test. And I apologize, I don't know what the acronym is. It's a really long scientific word that we'd all forget 15 seconds later, including myself. The point is, PLFA is a marker for these arbuscular mycorrhizal fungi. And so we can measure the levels of these mycorrhizal fungi in your soil and then determine whether or not practice changes result in an increase. In the example you're looking at on the screen, this was from a test field where I did the seed treatment. And what I did is I took a test that was in the treatment zone where we coated seed with mycorrhizal fungi and in a zone where we did not coat the seed with mycorrhizal fungi. And as you can see on the top of the heading there, where we had treated seed with mycorrhizal fungi, this soil test showed a 20% increase in mycorrhizae in that test. So that was really confirming to me as an agronomist to say, here's a product that we think would work to help us gain an advantage. I was able to go out and measure that what the product said it had actually was present in the system and offered an advantage. So kind of a neat test that can be run right alongside with the Haney to give you even more information about your soil microbial community. These are things we want to see change over time when we're starting to adopt various regenerative practices. I made that bold comment that mycorrhizal fungi might be the most important species on the planet. These are guys you want to see increase over time in your farms and fields as well.
Joe, I don't want to interrupt, but I will direct you to the chat box. There's a couple questions there, and I'm not sure if this is a good time to answer those, but I'll let you know they're there.
You bet. So I'll have a quick look here. Okay, so the first one from Greg here says, regarding Haney test results, do you have a chart comparing recommended min-max to compare parts per million of measured results in part? It's a great question, Greg. This is perhaps the biggest criticism I have with the Haney test is no, they don't provide reference values. And I've asked the lab owner, why is that the case? Why don't you give us a benchmark to compare these two? And he said, well, here's the deal. This is not like standard soil testing where universities have calibrated these across millions of acres and crop measurements. These numbers are very context specific to your own soils and your own conditions. Not an answer I'm completely satisfied with, but I kind of understand and respect where they're coming from, is that they can't give us a hard number of, let's say, 100 parts per million of carbon is a sweet spot, because for some environments, 100 is a lot, and for some other environments, 100 isn't much at all. And that depends on the soil type and moisture levels and a whole bunch of other factors. Unfortunately, we just can't apply that same type of logic as we could to, say, a phosphorus number, where regardless of conditions, your phosphorus just isn't going to move. It's not going to be subject to things like weathering and that kind of stuff. It's much easier to do a reference range for a parameter like phosphorus, whereas things like water extractable organic carbon, it's a much more unique type of measurement that is very context specific. So again, I share that frustration. I wish there was an easy button where they could say, yep, here's a number to benchmark it with. I will say, however, they do offer a PDF interpretation guide where they give some really vague ranges, in an explanation of what each parameter means. That PDF is available on the internet without even ordering a lab test. So if you wanted to go in and read this beforehand, you could certainly do so and get a sense for how they're explaining each of their parameters. Second question, do you have experience introducing mycorrhizal fungi on perennial crops like apples or grapes? Can I introduce these inoculum through drip irrigation? Not sure the rates. So I don't have personal experience with perennial crops, but there are many people that do, and they say absolutely. Mycorrhizal fungi are absolutely a part of these equations. Now, there's a different set of species that are applicable to trees. These are called ectomycorrhizal fungi. They're not the same as the endomycorrhiza that we use in annual crops, but they do have their own specific versions of mycorrhiza that are relevant. As far as rates go, I've got some information here I'll put up in my next screen. I realize I got 3 minutes to go, so I'm going to zoom through these last couple slides here and show you, I believe, what is the answer to that question. Okay. Quickly, we'll get back to this. Giant pumpkins. There's a reason why I'm showing giant pumpkins on the screen. I'm a competitive giant pumpkin enthusiast. What I wanted to show you here is that giant pumpkin size has grown at an incredible rate from the year 1993 all the way up until 2023. On the left-hand side of this graph is pumpkin weight. You can see back in 93, the world record giant pumpkin was around 750 pounds. Today, the world record giant pumpkin, as it stands, 2023, is 2,743 pounds. So we've taken giant pumpkins from 750 all the way to almost 3,000 pounds in less than a 30-year, or roughly a 30-year time period. How do we do that? It's mycorrhizal fungi. These things are incredible. And so around the 2005 timeframe, giant pumpkin growers started using mycorrhizal fungi as direct inoculants on the adventitious root systems. And that is what has allowed us as a hobby to take these weights at an ever-increasing linear way all the way up the scale to almost 3,000 pounds. So I could talk pumpkins for hours. It's one of my favorite hobbies. But in the interest of time and the answer to your question, yeah, they do make products for drip systems as well. You can do a soil applied drip application to already established perennial crops. That's completely feasible. Likewise, if you're starting new annual crops, this is what a package of this product looks like. It's a dry powder. You dip the seeds in the dry powder, put them in your mix, or you could just take the dry powder, mix it up with your potting media, and then put that in with your transplants. For the record, I don't sell products. I don't have any financial relationship with this company. I simply go hunting for products that I believe work. This is the one that I have used that I believe works. You may have heard of John Kempf. He runs a Regenerative Ag podcast. Listen to a few of his episodes. You'll get excited and addicted to mycorrhizal fungi in the same way I did. It's really quite inspirational stuff. And then real quick, if you're interested in this topic, you wanted to read more, this is an awesome book. 300 pages. It's all mycorrhiza. It talks about the importance of the species and the role that they play in the ecosystem. It's written in a way that's not necessarily for a technical advisor. It's very easy to read. It's lighthearted. It's even got some humor built into it. So with that said, boy, I wish I had another half an hour to share with you all, but I certainly do appreciate the opportunity to give you a brief overview of some of the soil health things that I am using. And if there's any last questions you have before I turn it back, feel free to fire away.